Hello, today topic is loss distribution and construction details of energy efficient motors. So first we discuss uh, the concept of loss distribution. Okay, so here the loss distribution is. So what is loss distribution first? How it is produces in a different areas, different rate areas. So here we take one example. That is a standard 10 HP electric motor may have an efficiency range of 81 to 88%. So first calculate how much loss can be produced in 81%, then 88%. From the two cases, what you understood. So that is the concept here in this slide only. So at 81% of efficiency, input electrical power is 9210 watts, losses 1750 watts. At 88% of efficiency, input of electrical power is 8477 watts, motor losses 1017 watts. So it is the two cases we consider from the same example for the same input, but we are getting output different, but the same rating of 10 HP. So what is that? Therefore, for the same output, the input can range from 8477 to 9210 watts. It is, what is that meaning is, increase in energy consumption and power cost also is 8%. So due to that reason only, it is nothing but a standard motors. It's not applicable for energy efficient motor. So what we understood, energy consumption also increasing and power cost increasing by 8%. So it is the main drawback. So why you consider energy efficient motors? So it is these energy standard motors can operate as a less efficient motor. From this analysis, you should understood. Okay. Then one more example, that is global effects from motor drive efficient improvement. So I'm taken as efficiency 0.1 increases. What about approximate cost of electricity saved? Then approximate amount of carbon dioxide kept up at atmosphere. So here, global increase in motor drive efficiency, approximate cost of electricity saved based on the average $5 per kilowatt hour, approximate around, that is carbon dioxide kept out at atmosphere. So 0.1%, $100 million, 0.5%, $3 billion for approximate amount is 50 million metric tons. So like 1%, $6 billion, 100 million metric tons, like that. Now power stages in induction motor. Power stages. I think already know that well known about this topic in machines EM3 in our third year first semester. So here we discuss same topic. So here power stages in an induction motor is power input to motor through stator. First given to the input to the motor. So it is considered stator copper and iron losses, rotor input via air gap. So from the rotor copper loss, mechanical power developed. So here we are getting as mechanical losses, that is friction windage losses. That is also called as a magnetic losses. It is called as a magnetic losses or constant losses, friction and windage losses. So not called as a constant losses. It is also one more type of friction windage losses, not as a constant losses. Sorry. Okay. Constant losses. What is mean by constant losses? Eddy current losses and hysteresis losses. Okay. So friction windage losses, one of the other type losses. And finally, we are getting is rotor output or motor output. So these are the power stages we are considering in induction motors. It is the basic concept. So what is loss distribution? So there is a two different types of losses that occur in a motor. The different types of losses that occur in a motor, that is copper losses, friction index losses, and stereo losses. So what is power losses? So these losses are major losses and typical amount of 55% to 60% of the total losses. So the presence of 60% of the total losses. What about core losses? Core losses are those found in the stator rotor magnetic steel. Okay. And what about friction windage losses? Friction and windage losses results from bearing friction, windage and circulating air through the motor only. So it is called as a friction windage losses. What about stator losses? These losses vary according to square of the load current. You know that equation, and are caused by leakage flux induced by the load currents in the laminations. Okay, it is these losses are within a limited range. The various motor losses are independent of each other, not same as for different types. That is 1 HP motor, 2 HP motor, 3 HP motor, 10 HP motor, like that. Not equal, not all the not for the same losses in the different types of the ratings of the motor. So it is different. So if you take one example of motor, power losses, core losses are one values. Take another motor, they are getting different values of that, not equal. Okay. Here, average loss distribution. So motor component loss and total losses. What are the motor component losses? Stator power loss I square R. The total loss 37%. Rotor power loss I2 square R 18%. Total loss. Magnetic loss 20%. Friction index loss 9, and stereo losses 16%, like that. So these are the average loss distribution in a given. If you take any motor, not taking a standard motor. Okay. And then typical of distribution standard, National Electrical Manufacturer Association design for some data is given for 1 HP motor and 5 HP motor. What are the losses will be developing? The manufacturer given, that is NEMA, National Electrical Manufacturer Association. Okay, so this NEMA can decided some manufacturer details for what about stator power losses, rotor power loss, magnetic core loss, friction index loss, stereo loss, total losses, output, input, efficiency, everything they mention. It is nothing but nameplate details for 1 HP motor and 5 HP motor. So 1 HP motor in watts, percentage losses, and per unit losses. So like that, they already defined the values corresponding. And increase in efficiency by 1 point. Suppose 1 HP motor, original efficiency 73 point. If we increase it 1%, so what is decrease in power loss required is 8%. Decrease in power losses is 8%. Suppose 5 HP motor, 85% are increases. So what about decrease in power losses is 11%. So like the 25 HP, 50 HP, 100 HP, and 200 HP motors. So from that up to we discuss what are last distribution different motors for 1 HP motor and 2 HP motors. So from that what we concluded is, so it is important for the motor designer to understand this last distribution in order to make the changes to improve motor efficiency while meeting other performance criteria, including lock rotor torque and breakdown torque, and finally power factor. That is a lock rotor torque and breakdown torque and power factor. However, as the motor efficiency and the horsepower increases, the level of difficulty in improving the electric motor efficiency also increases. Motor efficiency HP, that is horsepower, increases. What is the level of difficulty in improving the electrical motor efficiency also increases. Finally, the loss reduction can be achieved by using quality material and making some modifications in the construction details. So what are the modifications can be done in the construction means high grade materials are used by this. So by default, loss distribution will be also reduces in a energy efficient motors. Energy efficient motors. Thank you.